Hi there, my name's Ken Packwood. I work for the Fluke Corporation. I'm the lead facility mechanic. I'm also the HVAC specialist. And today I'm going to take a look at a piece of equipment that I repaired several weeks ago. As you can see, I'm in the janitor's closet. That's where a lot of our equipment is. For those of us who are in HVAC, we're in janitor's closet, small tight places or little rooms that are seemingly abandoned. But today we're in the janitor's closet, and the piece of equipment that we're going to take a look at is air handling unit number 7. Several weeks ago, I had a transformer fail in this unit, a control transformer. I found defective wiring. I found bad connections right there in the electrical compartment. I made the repairs, and today I'm going to double check on my repairs and make sure that the rest of our electrical is good. I'm also going to take an amp draw on the fan motor just to make sure there's no damage there. The first thing that I want to do is I want to de-energize power. My starter contactor is here against the wall. Obviously, this contactor works in the hand position all the time. That's its design, and so I'm just going to shut that off. I noticed that I didn't have a light in the on position, so I'm going to note that. Later on, I'll come back and after I de-energize this, and I will pull this apart. I will replace the operations light. That's important. But for now, I've disconnected the unit, disconnected the power, and because my work area is within a line sight of the contactor, I'm not going to lock out and tag out this particular piece of equipment. So let's open it up. We'll take a look inside, see what kind of work I did in there a couple of weeks ago, make sure everything's working well. And as I'm looking at all my wiring connections, everything looks really good here so far. The contactor is in good shape. None of the wires that I took apart and have put back together have fallen off. All my twist connectors are in good shape, and everything nice and tight on the controller. That's where I did most of my activity. Also right in here, everything's still very nice and tight, nothing loose, nothing coming apart, and so I'm pretty happy with that. My fan motor, I have right here a lead off the load side of the contactor, the black lead, that's the common lead on the fan motor, and I have what's called a tattletale on that, so that this communicates with the digital command system, and then on my laptop I can take a look and make sure the fan motor's running or not and verify that. But this is the common lead, and this is where I'm going to take my amp draw today on my fan motor. So let's get my tool. I'm going to be using today a Fluke meter that's relatively new on the market. I've had it for almost a year, and I really like it. This is the Fluke 233, and one of the things I like about this meter, it's very versatile: volts, AC, DC, ohms, millivolts. I can take temperature readings with it. I can check capacitors with it, and of course amp draws. But also this particular meter has a removable display, and because of that removable display, I'm not wearing FR gear today. I'm not wearing my fire resistant gear. All I have are my safety glasses and just good practices. And I'm going to do this. I'm going to check the amp draw in this unit while it's live, while it's running, and I'm going to do it completely safe. So the first thing that I want to do is I want to check my test leads and the circuitry within my meter. I make sure my test leads are in nice and tight. I put my meter on the ohm scale and I check continuity. I have good continuity there. That way I know my test leads are in good shape. No separation in the leads, and the circuitry of the meter is good. And so for now I'm going to turn that off, take these test leads off, and then I'm going to put on my clamp attachment. So I'm testing amps. So my red lead goes in the amperage, my black lead goes in the common. I'm going to test this on a millivolt scale. And now I'm set up, I'm ready to go on a millivolt scale, and I'm going to go back inside to the compartment and find that black lead right there. I'm going to clamp onto it. My meter is on. And what I'm going to do is I'm going to take the display off. Now this display is magnetic. I can set it off to the side right there. And I'm actually going to put the meter in the compartment. I'm going to use this great industrial strength magnet right here and just magnetize this to the electrical housing so nothing gets in the way of the fan motor or the belt. These magnets are great, really nice and strong. Fluke makes those. I've got a few at home in my refrigerator. Don't tell my boss, but it's holding up the shopping list. And then I'm going to put my cover back on. Once my cover's back in place, I can energize the circuit. I can get an amp draw on this motor. And then we'll go over to the starter contactor, energize it, energize the controller, wait for the fan to come on. Once the fan comes on, I'll be able to get an amp reading without using any PPE other than my safety glasses. I expect to see about 2.3, or excuse me, less than 3.2 amps on this motor. Right now, with the fan on a load, I'm drawing 2.1 amps, 2.2. I can press hold and it will capture the highest amp reading. If I'm in a dark environment, I can also turn on a backlight. I don't know if that shows up very well in the video, but if I'm in a dimly lit room, there's backlighting, and I'm pretty satisfied with my motor. It's drawing 2.3, no more than 2.4 amps occasionally, and I'm satisfied with my wiring, satisfied with my amp draw on my fan motor, and now it's just a matter of de-energizing the circuit, pulling my meter out, closing everything back up, and I'm ready to go to the next job. All right, so there we have it. We've been able to open up the electrical cabinet, take a look at the transformer that I replaced, all the wiring, get an amp draw on the evaporative fan motor, close it all back up, and I got to do all that without putting on any PPE other than my safety glasses and using my insulated tools and just good practices. I'm able to do that because of the meter I'm using, the 223. I like the meter, I recommend it. I don't just recommend it because I work for Fluke. I recommend it because it's a practical meter for HVAC. I'm really proud to be a part of the Fluke Corporation. I've worked here 4 years, but I've been a longtime user of Fluke tools, and I recommend them to you. Thanks for joining us today. My name's Ken. I'll see you next time.